Hi friends, welcome you all to the last 90 days to CAT series, and today we'll talk about mensuration. In this part, we'll revise mensuration completely and we'll also cover last 5 years of actual CAT questions. So I hope all of you are following the booster cards also. The booster cards were shared on Instagram if you've seen it already, and obviously the detailed videos are going to come on YouTube. So mensuration, let's see what are the key figures. The key figures, if you see, are cube, cuboid, cylinder, cones. Then you have prism and pyramids, spheres and hemispheres, and then there are some miscellaneous figures like frustum, which is obtained out of the cones. And there are hollow cylinders, which are again a variation of cylinders. So let's see how do we simplify the concept. Consider the first case of figures. First case is when top and bottom is the same. What's an example? An example can be, let's say, a cube, right? So the top as well as the bottom, top and bottom are the same. Cylinder also, here your bottom is also a circle and top is also a circle of the same radius, right? Similarly with prism also. So such are examples of the first category of figures where top and bottom is the same. So here we have very simple formula. The curved surface area will be the circumference or perimeter of the base into height. For example, let's check out for a cylinder. For a cylinder, what will be the curved surface area? First you calculate the circumference of the base. Circumference of the base will become 2 pi r, right? Circumference of a circle. Curved surface area will not be nothing but circumference into the height. So 2 pi r into h. That's the curved surface area of a cylinder. Right, so that's the first part, and you can apply it to all the figures where top and bottom are same: cube, cuboid, prism, right? So no need to memorize each and everything. As you will practice, you will remember these things, and even if you forget, you can always use this small form and calculate it, right? What will be the total surface area? Total surface area will be curved surface area plus 2 into the area of base. Let's apply this again in case of cylinder. So you have curved surface area already, plus twice into area of the base. Area of the base as well as area of the top, both will be pi r square because these are circles. So add twice of this to the curved surface area and you will get the total surface area here, right? And again, this can be applicable to wherever top and bottom are the same, right? And finally, volume is area of the base into height. Let's again apply this wherever top and bottom is the same. So cylinder, area of the base is nothing but pi r square. Multiply this with the height, which is h, and you get the volume. So the volume is pi r square h. Second classification is whenever top is an apex point. For example, in case of a cone, you don't have the bottom same as the top. You have a circle in the bottom and on the top you have a point. Similarly with pyramids, right? So whenever such conditions are there, then the curved surface area will always be circumference, half of that into the slant height. What is slant height? Slant height is not this perpendicular height. Slant height is the inclined height. For example, in this case, you can see a right triangle. So the slant height will be given as root over h square plus r square, right? By Pythagoras theorem. Right? So that's the slant height. Total surface area will be curved surface area plus area of the base. Obviously, because area of the top is almost negligible, right? So all you have to do is just add this. And volume will be 1/3 the area of base into height. I hope you're all taking screenshots of these cards so that you can print them, keep it handy with you for revision later on. Moving forward, let's have a look at the third case, sphere and hemisphere. Let's understand how do we operate sphere, or how do we sort of remember these formulas easily. Always remember, for a sphere, total area, your total surface area, which is the curved surface area or total surface area, one and the same thing, will be 4 times the area of the circle that's there with the largest diameter, or the radius of the sphere. So if you see this circle which is there absolutely in the middle, the area of this circle is pi r square. The area of the sphere is 4 times that. So area becomes 4 into pi r square. 4 into area of the circle. Similarly, if you see a hemisphere, your curved surface area will become half of this. So 2 pi r square. But then you have a base also, right? So total surface area will become 2 pi r square plus the base, therefore 3 pi r square. How do you get to the volume? Understand this very simply. If you understand the basics of differentiation, volume of a sphere is given as 4 by 3 pi r cube. Now, if you just differentiate it with respect to r, this becomes 4 by 3 into pi into r cube. The differentiation will be 3r square. So this becomes 4 pi r square, right? Which is the area of the sphere. This is one way of understanding it in our head as to how to, fit the two things here together and to remember it better. Once you know that the volume for a sphere is 4 by 3 pi r cube, the volume for hemisphere will be nothing but half of it, which is 2 by 3 pi r cube, right? So keep taking screenshots so that you can keep it handy for revision. And finally, if we talk about a hollow cylinder or a frustum, always remember a hollow cylinder is same as the first case, which is the case where top is equal to bottom. You can use the same case and calculate it. Don't memorize these formulas. You don't actually need to. If you know the concept, all you have to do is calculate the circumference here, multiply with height, you get curved surface area. Add the base and top to it, you get total surface area. And obviously, you calculate area of the base, multiply with height, you get the volume also. Similarly, frustum, all you want to know is the concept of similarity. For example, let's say what is frustum? If you cut a cone from the top, parallel to the base, you get a frustum, right? So if you see here, if let's say this is R1, the total height is H. If we take, there is a smaller cone, if I basically build a cone here and take this height as X, I can calculate this X using similarity. Why? Because triangle EAD will be similar to triangle EBC, right? So you can use this concept and solve the question, maneuver and solve it. Don't need to remember it. Let us try and apply these concepts into questions. A solid right circular cone of height 27 centimeter. So the height is given to us as 27. Is cut into two pieces along a plane parallel to its base at a height 18 centimeter from the base. So at a height of 18 centimeter, so this top height will be 9 because total height is 27. If the difference in the volume of the two pieces is 225. So we have a top cone. Let's say the volume of the cone is X. And we have a complete cone also, right? So this bigger cone, let's say the volume of that is Y. Quite clearly, if let's say this is A or the radius of the smaller cone is A, the radius of the bigger cone will become 3A. Why? Because the height here is 9. The bigger height is 27. The ratio will be same. Why? In case of similar triangles. So for example, this is ABC and this is DE. So this is the exact same thing which I was talking about in the last concept. You see the frustum here, right? So just apply this concept. Triangle ABC and triangle ADE are similar. So therefore their sides will be proportional. So AB upon AD will be same as BC upon DE. Therefore this radius, if this is A, this will be 3A. Volume of the smaller cone will be 1 by 3 into pi into r square. Let's say r is A. So A square into height is 9. And the volume of the bigger cone will be 1 by 3 into pi into 3A square into H is the bigger height, which is 27. If you see, this height is 3 times and this radius square becomes 3A square, so 9 times. So this is 9 times. So overall the volume is 27 times. So if the smaller cone and the bigger cone, the ratio is 1:27. So if this is X, the volume of the frustum must be 26X. The difference between the two pieces is 225. So difference will be 26 minus X. 25X is 225. So X is equal to 9. The volume of the original cone will be 27 times 9. Therefore 243. The base of a regular pyramid is a square and each of the 4 sides is an equilateral triangle. Length of each side being 20. The vertical height of the pyramid. So what is the vertical height? From the center of this base to this apex point. That's the height that we are planning to find out. Let's see, this is 20, right? So this, if I draw a perpendicular from this point to here, this will be half of 20, so 10. This is what I want to find out. If I join this point A to D, let us understand this line AD. If I take this, the side section ABC, I draw this perpendicular here. This is AD. So if this is 20, then this must be root 3 by 2 into 20. So therefore 10 root 3. So if this is 10 root 3 and we know that this is equal to 10, then by Pythagoras theorem, quite clearly this is 10 root 2. I hope this is also clear. A man makes complete use of 405 cc of iron, 783 cc of aluminium and 351 cc of copper to make a number of solid right circular cylinders of each type of material. Now these cylinders have the same volume and each of these has a radius of 3 centimeter. If the total number of cylinders is to be kept at a minimum, so height has to be maximized, right? So then the volume will be maximized and therefore you will have lesser number of cylinders. Remember, we have to keep the volume same. For all these, we have to figure out one common volume. So that one common volume also has to be highest. Therefore, the number of cylinders will be minimum. If you understand the concept of HCF, all you have to do here is take the highest common factor from each of them. What's the highest common factor? If you see 405, 783, 351, the highest common factor quite clearly is 27. Now, this should be the volume of every cylinder that we are making here. And cylinder will be pi r square into height, which is equal to 27. Now, we know the radius is 3. So r square becomes 9. This becomes 3. So h becomes 3 by pi. Now we have to calculate the total surface area. Remember, total surface area of cylinder is given as 2 pi r into h plus r. Now h is 3 by pi and r is equal to 3. Quite clearly, when two of them will go in here, we must get a 1 plus pi here. Think about it. 3 plus 3 by pi. It is certainly going to give you a 3 common outside and a pi plus 1 here, right? And a pi here in the denominator will get cancelled from here. So a pi plus 1 is mandatory. We don't need to calculate it completely. The answer is answer option D. I hope this is clear to you. So keep saving time wherever possible. A good question from CAT 19 slot 2. We have a rectangular face of a brick having the diagonals. Now let's see, we have 3 dimensions to a rectangular brick, right? So let's say we have a length, breadth and a height. Let's say that there is a certain order to it. So A greater than equal to B greater than equal to C in terms of length. What we need to find out is the ratio of length of the shortest edge to the length of the longest edge, right? So we have the diagonals here. So if you see, let's say this is A and B, the diagonal will be root A square plus B square. So if you take two of them, the diagonal will be root A square plus B square, root B square plus C square, and finally root A square plus C square. Now in this condition, quite clearly, we'll have A square plus B square, that's the biggest, A square plus C square, that'll be second, and B square plus C square smallest, so third. If you just square these numbers, A square plus B square is the square of the biggest one, so that becomes 15. And B square plus C square, that's the square of the smallest, so that becomes 3 square, which is equal to 9. And finally, if you square the A square plus C square, you should get square of 2 into root 3, 4 into 3, which is 12. If you subtract 1 and 3, you will get A square minus C square is equal to 6. And you have A square plus C square is equal to 12. If you solve these two, 2A square becomes equal to 18. So A becomes equal to 3. So this becomes 3 square 9. So C becomes equal to root 3. Longest to shortest or shortest to longest, the ratio is 1 is to root 3. I hope this is also clear to you. A right circular cone of height 12 feet stands on its base, diameter 8 feet. So radius is 4 here. And the height is 12 feet. So that is also given to us. This is 12. The tip of the cone is cut off with a plane which is parallel to the base and 9 feet from the base. If you take 9 feet from the base, you will have 3 feet here, which basically means that we can again use similarity as we have used in the first question. So ABC and this is ADE. So if this is 3 is to the total, which is 12, so 1 is to 4. So the radius must be here 1 and this is 4, so 1 and 4. So volume will be 1 by 3 into pi into r square, which is 1, into height, which is 3. For the bigger cone, 1 by 3 pi into r square, which is 4 square, into height, which is 12. So this is 16 times, this is 4 times. Total, the smaller cone, if let's say that is x, the bigger cone in terms of volume is 64x. The volume of the remaining part of the cone, let's say we calculate the smaller one. So this part will obviously be 64x minus x, which is 63 into x. Let's calculate x very quickly. So 1 by 3 into pi, which is 22 by 7, into r square, which is 1, into height, which is 3. So this becomes 22 upon 7. So just multiply this. So this becomes 9 times. The answer is 198. The base of a vertical pillar with uniform cross section is a trapezium whose parallel sides are 10 cm and 20 cm, while the other two sides are of equal length. So if this is 10 and this 20 and this is isosceles trapezium, so as a property of isosceles trapezium, this is 10, this will also be 10, this is given to us as 12. So the remaining 10, because this BC is 20, the remaining 10 will be distributed uniformly. Here we'll have 5, here we'll have 5 by symmetry, 12 and 5. We have a perpendicular. Pythagoras, we'll have 13 here and 13 here. What do we need to calculate? Total surface area. What will be the total surface area? In this case also, top is equal to bottom, case number 1. Therefore, curved surface area here will become perimeter of the base, which is 13 plus 13, 26 plus 10 plus 20. So curved surface area becomes 56, which is perimeter, into the height, which is 20. So that becomes 1120. And total surface area will be curved surface area, which is 1120, plus twice the area of the base. What is the area of the trapezium? It is given as half into sum of parallel sides, 10 plus 20, which is 30, into the altitude, which is 12. This becomes 180. So twice the area of the base, so 360. The answer to this question is 1480. A solid metallic cube is melted to form 5 solid cubes whose volumes are given. Always remember, whenever the melting problem is there, the volumes will remain constant. So we have 5 solid cubes. Let's say the volumes are a cube, 8a cube, then 27a cube and 27a cube. If you combine all of them, the combined volume will become 64a cube is the volume. So 64a cube is the volume of the bigger cube. So what's the side here? The side here will become 4a, and therefore what will be the surface area? 6 into the side square, which is 16a square. The surface area of the bigger cube, total surface area, becomes 96a square. Now let's calculate the surface area of these individual squares. Here the side will become a, therefore 6a square. Here also the side will become a, so 6a square. Here the side will become 2a, so 6 into 4, so 24a square. Here the side will become 3, so 6 into 9, so 54a square. And here also 54a square. So this becomes 24 plus 12 is 36, this is 108, so 144a square. What is the change in the surface area? What is the percentage by which the sum of the surface areas of this individual cubes exceed the surface area of the original cube? That is quite clearly from 96 to 144, increase of 48, which is 50% of 96. The answer is answer option B. A ball of diameter 4 cm is kept on the top of a hollow cylinder standing vertically. The height of the cylinder is 3 cm, volume is 9 pi. So pi r square h. So pi r square h is 9 pi and h is 3. So r square is equal to 3. So radius is equal to root 3. Radius of the cylinder is root 3. We also have this ball of diameter 4 cm. Quite clearly, it is not going to fit this. Okay. The diameter is 4, so radius is 2. So let's say this is the center of the sphere. So this is, let's say, 2. So then this must be, by Pythagoras theorem, this will be 4 minus 3, this will become 1, and here will be the radius, it will be 2, and this will be the height of the cylinder. The height of the cylinder is 3. So what is the vertical distance? 3 plus 1, 4 plus 2, 6. I hope this is also clear to you. With that, we have solved all the questions from the last 5 years of mensuration. If you've revised the basics and have solved all these questions, you are pretty much safe from a mensuration standpoint. Revise this topic once more before CAT and you are good to go. God bless. Take care. Bye-bye.